Hi guys. Good evening, everyone. I hope I'm audible to everyone. Please let me know in the comment section. Hi all. Yeah, session started already. Gaurav, hi Gaurav. Good evening. Okay, we'll just wait for like 1 or 2 more minutes. I think your friends are yet to join in the session. Okay, let's just wait for 1 or 2 more minutes. I think some people would come off, will join our session. We just went live now. Okay, great. So let's continue. Let's continue from the point where we left out, guys. For the time being, I would be sharing the same whiteboard where we were discussing something in the last class, in the previous class. Yep. Yeah. Hi, Srisha. Hi, Rishmita. Hi, Neeraj. So I'm sharing a screen with you all, guys. Just give me a moment. I'm opening that whiteboard where I was scribbling something and I was explaining the linked list. So in the previous class, we were discussing insert at beginning. We were discussing that function insert at beginning. I have already defined it, but I'm yet to discuss some minor changes in that. Some concept which is very important. Some minor changes, but it is very important. Very important, which I didn't discuss in the previous session, which I'll be discussing in this class. Okay, yeah, Shirshan, no issue. You can watch today the previous session, like previous 2 days session. Okay, it is still there in on our channel in the YouTube, so you can check it, and you can also fill the attendance for the same. Yeah, good evening, Ravindra. Hi, good evening, Ketan. Okay, let's see. Like, is it ready? Is it up? Because I would be sharing. Okay, just give me a moment. No problem at all. Like Shirsan, there's no absolutely no problem. You watch this session, and maybe after the session, you can watch the previous 2 days session from YouTube, and you can fill the attendance for the same. Okay, do join the community, but because there you would get the assignment and materials. So yeah, it's time I share this whiteboard to all of you. Is it visible, guys? Is it visible to you all? Okay, I think it's initializing now. Some screen. I suppose, like, I hope everyone is able to see some extra screen apart from my camera, because that is where I'm sharing this whiteboard actually. Okay, yeah, great. Okay, so this is where we were stuck in the previous session, that we were talking about this insert beginning function. Just give me one moment. I'll just zoom out a bit. Okay, fine. Yeah. So this was our point of discussion. We were discussing this insert at beginning function, and we discussed that if head equal to, first of all, we had created a new node. Okay, and np is pointing to that new node. Okay, right, and we check if head is equal to null. That means if there is no node at all, if there is if the linked list has not been created, then what we'll do, we will make head point to the new node directly, because this is the first node, very first node which we are inserting, and you just return back. Okay, now if head is not null, that means there will be already some nodes in the linked list. Then in that case, what we are doing, first we need to form this link. So np of next, we are storing head, and in head I'll be storing np, because head should point to the new node, because I'm inserting a new node at the beginning. So this should be the first node. This is already explained in the previous class. I hope like this is clear. I'm not getting into this once again. You can check it back, the previous session where I have explained this code actually. Right now I want to discuss the modification we need to do here. Okay, what modification and what is it is about. Let's see here, guys. See, guys, if you remember the code, I hope, like, I think I had said in the previous session, please rewatch the session before you come to this session. Okay, if you remember the code, in the main function I had written, I had created head. Okay, I had created head, which was pointing to the first node, right? Okay, so that is the original head, which is pointing, which is the initial point, which is the starting point for the linked list we have created, right? Okay, now if you see in this function, insert beginning function, this insert beginning function will also need head. Okay, and head is not global. If you remember the code, if you have seen, if you are rewatch the video before coming to this session, you see, guys, head pointer was declared, was created in main function, so that was local in main. And even here in insert beginning function, we need the head, because we would be starting with head node every time. There is no other way to access the linked list, to access the nodes in the linked list. It's always head node from where we start the linked list, right? So we start from the head node and then we visit all other nodes subsequently. So head node is the starting point, and head node is the entry point to the linked list, right? This is what I've already told you. But the problem here is, we had created that head in main function. So there was a head in main function, right? And we also need head here in this beginning function. So what we need to do is, guys, here, so along with the data for the new node, you also have to accept, okay, you need also head here. Apart from the data for the new node, you also need this head. Okay, so in main function, while you call insert beginning function, you pass the value of head and the data along with it. Okay, please remember this. Along with data, you also send head, value of head. Value of head is nothing but address of the first node. That is what you are sending to the insert beginning function. When you are sending it to the insert beginning function, I will just say this as IB function. Let's say IB function. This is main function. This is insert beginning function, IB. So guys, see here very clearly, it's a concept of local variables actually. Okay, so there is one head in main function, there is another head in local variable in insert beginning function. Okay, right? So there are two heads, one is local in main, one is local in insert beginning function. Understood, everyone? Okay, so both are different actually. They might have the same value. Let's say initially it is 101, and 101 is being sent to the head of IB function, so it is also holding 101. So let's say this is the main function head, and you have one more head that is of IB function, insert beginning function. So right now it is holding the same value, 101. Are you getting my point, guys? Are you getting, all of you, are you all getting my point, what I'm talking about here? So I'm talking about local variable concept. I have two head here. One is in main function, one is in this insert beginning function actually. So both are different, but I'm sending from main function, I'm sending the value of the head, that is 101 for the time being, that is being sent to the head of insert beginning function. Okay, right? So right now, just assume that we don't have this new node for the time being. Just leave it. Okay, just think that, okay, there are like head 101, and it is pointing to here. So we had this. Now we are talking about inserting a new node. So what is the first task we are doing? The first task which we are doing is we are creating a new node. Okay, let's say data is 5. Okay, let's say data is 5. So initially it would be null, right? Okay, initially it would be null. Now, if you want to insert in the beginning, as I have already said this, so you need to do one thing here. You need to link this up, and then you need to make this head point here. This is the original head, main function. Okay, main function head is the original one because we had created it in main function. Okay, right? So both the head here are different. In main function, we have one head that is created locally. Okay, I think I should show you the code only then. Just give me a moment. I'm opening that code. I'm sharing that code. Okay, I'll just show you. Just give me one moment, guys. Let me just open that file and I'll have to share it with you all. So linked list. Okay. So now let me stop the screen share of this and let me share. Okay, fine. So now I think you are able to see. So I'm talking about this head, guys. I had created head in this main function. This is local in main function. Now I'm saying I'll be needing one more head in this insert function. Okay, I'll be needing this. So I'll need here one more head, which is local in the insert beginning function. Right, this is what I'm saying. So this head, this main function head, this is local in main function, and this head, it is local in insert beginning function. Both are different memory location, and they are local to the respective function they are declared in. That's what I'm saying here. Okay, right. So if we go back to the whiteboard where we were discussing things, let me share with you that whiteboard again, guys. Yeah, I hope everyone is able to see the whiteboard once again. So that's what I'm saying here. We have two head here. One is local in main function, one is local in insert beginning function. So now my question to you is, if I change here the value of head, which head would get changed? Okay, for now, for example, so you had a main function head which is null. Okay, even you have the insert beginning function head which is also null. Now because let's assume that we are considering the situation where there is no node, linked list has not been created. That is why we like this condition is satisfied. Head is null. When head is null, that means no node has been created. So we are storing np in head. Okay, what is np? Np is nothing but the new node 5 null. This is np. Maybe address is 501, right? So np is holding 501. So I'm trying to store the value of np, that is 501, in head. My question is, which head would be updated? Head of insert beginning function or head of the main function, the original function? You know, right, the concept of local variables, guys. Just give me some confirmation. Just give me the answer, guys. Which one would be updated here? If I write here head equal to np, np is the value 501, address of the new node that you are storing in head. Okay, in which head you are storing? Head of main function or head of insert beginning function? Both are local, right? Yeah, Gaurav, you are correct actually. Yes. Always remember this, guys. When you are inside a block or in a function, and if you are using a variable, always it would use a local variable. So here we have two variables like head with the name head, but one is of main function, one is of insert beginning function, and we are making changes. We are using the name head inside insert beginning function. So whatever changes you are actually doing, those changes would be done to the local head, that is your head of insert beginning function, right? So this head would now point to this, but you haven't changed, you haven't made any changes to the original head. Original head is still null. So as soon as you would be out of this function, as soon as you would be out of the function, when this insert beginning function would get over, guys, this is a local variable, so this would get deleted and you will have your original head still having null. So even then you have inserted a new node, when you print it after that, you'll get no node or no linked list is empty. So that's the whole problem here. That's what I wanted to explain here. Okay, so along with changing the local head, you should also change the original head, right? And how can we do that? Is it's very easy, simple. What you do is, see guys, you just write here return head. So whatever changes you are making to head, you are just returning the value of head, and that should be stored in the original head. Okay, so in main function, whenever you are calling insert beginning function, whatever this insert beginning would return, that would be stored in the head of main function, so that this 501 would also be returned here, and now a head function would also point to the new node. Okay, right? And then when you come out of this function insert beginning, let this be deleted, no issue. You already have changed the value of original head. Just like head is now pointing to the new node, so yes, it's fine, completely fine. Okay, so that's what I'm talking about here, guys. So whenever you are changing head, you return that, and when you are returning head, please remember this is the way to call the function. Okay, so whatever insert beginning will return, that would be stored in the original head of main function, so that the original head which is in main function would get changed. Okay, see guys, let me be very frank, this is not the only way of implementing linked list, but I feel this way it's very easy to understand actually. Okay, so this is insert beginning function completely. So let's implement it like quickly, as we already have discussed how it works. The function definition I already have written here the complete function definition of insert beginning. So I'll just write it in the code. Okay, I'll just write it in the code, and then we would like move on to the next topic. Where is code blocks? Yeah, I got it. So now, first thing first, we would create a new node. So let's say np. I will call this create function. That is why I have defined the create function. That is the whole task of create function, and I'll send this x there. Right. So now I'll write here if head is null. So guys, you can write. I think this is very. Let me zoom in a bit. I think now this should be fine. If head is equal to null, if right, this is also fine. Or else guys, in the same place you can write not of head. Same thing, head equal to null and not of head, both would mean the same thing. Why? Let's see. If head is equal to null, it would give you true. Not of head, if when head is null, not of null would give you true. Okay, if head would be any valid address, then not of a valid value would be false. So when you are getting true, when head value is null. So basically it is working same manner. Okay, so you can write if head equal to null, or you can write if not of head. If not of head, what we were doing? Simple, we were just assigning np to it, and we just return head. Okay, just kidding. Yeah, so that's it. And then finally, if head is not null, then we basically we are doing np of next arrow operator, np of next equal to head, and then head equal to np, and finally return head. Okay, so this is the complete definition for insert beginning operation, guys. Okay, so two scenarios we are talking about. Either the linked list would be empty and you are inserting the very first node, Otherwise, there would already be some nodes in the linked list. Then you are adding a node at the beginning. That's what this whole insert beginning function does, right? So you can now finally actually you can finally call this insert beginning function here, and return type here it should be node star and not void, because I'm returning head. Head is nothing but it would when you write return head, basically it is returning address of a node. So return type should be node star and not void. Just change it, node star insert beginning. Okay, this is it. Then let's call it, guys. So how do we call? I have already said you to call this. You write head equal to insert beginning, pass the head node address and the data. That's a 10. Okay, maybe I want to call it once again. I think I just can copy it and change the value. Actually, I want to call it 3-4 times. I want to insert some 3-4 values at the beginning, just to change the value. It will be done. Then let's say 30. Then let's say 40. So I want to insert this 10, 20, 30, 40 at the beginning. So 10 should be inserted first, okay, because linked list should be empty before that. 10 is the very first node, guys. Then 20 would be added at the beginning before 10. Then 30 should be added before 20. So that should be the first node. 40 should be added at the beginning. So 40 should be the first node. So when I display this linked list, what I should get is I should get 40, 30, 20, and 10. If I compile it, and run it, will not get any output because we haven't yet displayed the list. So let's see, guys, let's display the list also, just to get verification, just to verify yes we have done the function correct. So let's just write a display function. Okay, so display is nothing, we just need, like, return type should be void because we don't have to really do any operation. We just want to iterate and display all the elements there. That's it. So void display, maybe name it as list, display list. Obviously it would also need the starting point. Okay, so even here I have missed out. So node star head and int x. Yeah, let us define this display list. Okay, now how to display this list? Let me get back to the whiteboard. I'll explain there something. Okay, let me reshare the whiteboard, guys. I'll be explaining there how to display things. See, so just consider, first of all, very first thing, if there is no linked list, if there is no linked list created, or if there is no node in the linked list, so you can check it. If head is null, then there is no node to display. So you can just come back from the function display. But if there are some node, then you need to print it. So let's talk about the second scenario where there are nodes and we need to print it. So I'm drawing some nodes actually. So let's say this, yeah, let's say we'll talk about 4 nodes. So let's say address is 101, 201, 301, and 401. Let's say 40, 30, 20, and 10. And this is the head node, head 101. Okay, so what I'll do here is, guys, to iterate, I just want to visit each node, and while visiting I want to print data of each node. So for this case, what I'll take is I'll take a temporary pointer. Okay, I'll make this temporary pointer point to 101, the head node, because this is the entry point, this is the starting point. Okay, right? So what I'll do, I'll print each data. I'll print temp of data. So it will print me 40 first. Then I need to shift this temp to the second node and print that data. Then I need to shift temp to the next node and print that data. And I need to shift temp to the next node and then print that node data, right? How can I shift temp to the next node? It's very simple again. You just write temp equal to temp of next. What is temp of next? This is 201, this is 301, this is 401, this is null because there is no node after it. We already have discussed this part. Okay, so when you write temp equal to temp of next, temp of now temp is pointing here, temp of next is 201. So basically you are storing 201 in temp. So when you store 201 in temp, it is not pointing to here anymore. Now temp is pointing here. So you have shifted temp to the next node, guys. Okay, so this is how you shift temp to next node, but there would be a point where you have to stop. Okay, this is a repetitive step actually. Print current node data, shift temp to the next node, print the data, shift temp to the next node, print the data, shift temp to the next node. So this is a repetitive process, so obviously we'll go for a loop, right? Iterative steps. So let me use a while loop, but somewhere we need to stop. So that's where the condition that's where we need this condition, the stopping condition of the loop. So what is the stopping condition of the loop, guys? Okay, it's very easy. You just have to write while temp, or you can say while temp is not equal to null. It's same thing, guys. Okay, if you write while temp not equal to null, or if you just write while temp, both are same thing. If you write while temp, it means till temp is valid value, the loop should continue. Whenever temp becomes null, then you would be out of the loop, condition will be false. Even here it is the same thing, we're checking till temp is not equal to null, run the loop. When temp would be equal to null, then you stop it, right? Okay, so temp is here now, so 30 would be printed, then temp would be here, 20 would be printed, now temp would be here, 10 would be printed, because right, next time temp would be null because you are storing temp of next in temp while shifting it. So next time temp value would be null, so this condition would be false and you will out of the loop. By the time it would have been printed already 10, 40, 30, 20, and 10 for the entire linked list. So this is how the display works, guys. Okay, first of all you need to check whether there is any node in the linked list. Okay, if head is equal to null, then just return back, you don't have to do anything. But if head is not null, okay, then you need to do this process. Okay, make a temp, like make temp point to the first node, print its data, shift temp, print the data, shift temp, print the data. This will continue till you reach null, till you visit all the nodes. Finally you will reach null and you will stop there. That's it. That is the whole thing here. That is the whole thing we are doing here. Okay, right? So let me implement this for you. Let me show the code actually. Okay, let me reshare the code blocks because that is where I'll be writing. Yeah, first thing what I'll do here is I'll be checking if not of head, like if head is null, then I'll just print a message here, no node to display. Okay, and then return back because nothing to do. But if let's say if head is not null, then I will take a temporary variable which would be pointing to the first node, then the repetitive step which we just discussed actually, while temp till temp is valid, what we need to do is we need to print the temp of data, right? Okay, I need a space after that. But print the data, give a space. That's what I want. And shift them to the next node. That's what I am doing here. This is the whole thing about display. This is the whole thing I'm talking about display here. So just call the display function in main function, guys. Here after inserting this for node, we can just call the display list function. It should display us the linked list. So if everything is done correct, then we will get the output of the linked list as 40, 30, 20, and 10 because we have done insert at beginning operation. Let's compile it, guys. I'll just go with directly build and run, compile and execute directly. If it has error, then it will show us. Yes, that's some error. What is the error here? Malloc was not declared in this scope. Okay, I think I have missed out the header file for that. As include. How about not using malloc and using new? It should be, it is used in this, right? So using new operator is very easy, guys. What you can do is you can just write new node. That's it. Node star nptel equal to new node. So that's why, that's how you can do it. Let me now execute. Oh, display list. I need to pass the head node address, head value. Yeah, that's what I missed out. Now let's say compile and run. It seems there is no more error now. Let's wait for confirmation. Yeah, there is no more error, guys. No error, zero error, and it has executed successfully. So I'll be just showing you quickly the output. Scene actually, output screen. Let's check it out. Okay, see guys, we are getting output 40, 30, 20, and 10. We inserted first 10, then 20 was inserted at beginning, then 30 was inserted at beginning, then 40 was inserted at beginning. And when we are printing the linked list, we're getting the same here: 40, 30, 20, and 10. Okay, so that's how you implement, you do insert at beginning operation, and along with that we also learned display operation. Okay, right? I hope everyone understood this. Anyway, I'll be sharing this code, guys, with you all, so you don't have to worry about that. Okay, anyway, I'll be sharing the code with you. This code I'll share. So guys, looking at this, you can easily like that would be an assignment, guys. Like you need to implement insert at end. Okay, take that as an assignment. Actually, insert at end. I think I have not posted assignment for the previous day, like the previous day two. I'll be posting today, guys, like day two assignment and day three assignment today, like along with material. This is the material, guys, for the previous day, also for this day. So I'll be sharing this. Along with that, I'll be posting two assignment, one for yesterday, the yesterday's class, and one for today's class. Today's assignment, right now I'm saying it is actually insert at end. You need to define it. Okay, I'm just writing the prototype here. You need to complete that. Anyways, you'll be getting this material with you. Just finish that. Insert and so even this will take head address everywhere. Like we'll need the head address, head node, and the data. Fine. So just implement this. I'm just mentioning the prototype here. You uncomment this and define it later. This would be your assignment for today. Right. Okay. Fine. Now, next, one thing I'll do here is we are already in code blocks, right? Let's see this. I would also, along with this insert beginning, I will also talk about delete from beginning. Okay. Just focus here. Node star delete beginning. We need this head node address. Okay, and we don't need any argument there because we are deleting, we'll be deleting a node from the beginning, so we don't need any argument. Insert, in insert we were sending argument because this is the data for the new node that we are willing to insert, but deleting, it's just deleting, so we don't need any data here. But yes, we need the head node, right? And this is this delete beginning, so we would be changing the head address, guys. Okay, so let's define that. So node star delete beginning. So it is taking head address. First of all, very first thing, guys, if you're trying to delete some node in the linked list, then there must be some node already in the linked list to delete. If there is no node, then obviously you won't be able to delete, right? So that's the first thing I want to check. If head is null, then you just print a message: list is empty, no node to delete, or something kind of that. No node to delete. Okay, and you just return back. Okay, you can just return the same head actually. Head is null. You'll just return null, the same thing. Okay, nothing changes here. How do we call in the main function? Same way, like we call the insert beginning function. Here, you can just call here like head equal to delete beginning pass head. So when head is null, it would again return you null. Yeah, no harm done. The same thing. There was no node. Again, you are getting null as the return value. It would be stored in head. So there would be no problem at all here. Now, if head is null, this is to be done. Just print no node to delete and you return back. But let's say there is the let's say head is not null. Okay, so what you would do? So you'd be deleting the first node, right? Basically, you want to delete the head node because this is delete from beginning. So what we will do here is first task is to okay, you take a temporary node and make it point to the first node. Okay, so now head value I'm storing in temp. So temp is pointing to the first node, right? Then you change the head to next node because head should now the second node should be the beginning. Second node should be the head node now. So that's what I'm doing here. Head equal to head of next. So I'm storing the second node address in head. So now head is pointing to the second node. I have cut down the first node from the linked list. Okay. Now temp is pointing to the first node, which is to be deleted actually, right? But anyway, we have cut it down from the linked list because linked list starts from head node. I have already changed the head node here. The one only one thing left out, guys. Or no, sorry, two things left out. First is as here it is dynamic memory allocation, so you need to deallocate it, but the user should be deallocating it. Otherwise, we discussed the problem of memory leak, right? So that's why we would free it up. That is temp. When you write free delete temp, the dynamically memory allocate the node would be deallocated. The memory would be deallocated, and finally you can return the new value of head because this also should be stored in the original main function head. So this is the delete beginning function. Okay, this is the beginning function, right? Delete beginning function is this simple. So if I show you let me compile this once. I hope I have not made any mistake here. Yeah, absolutely no error, guys. So let's call this delete beginning function once, and obviously to verify we need to display, right? Just do that. Let's do that and see for ourselves if everything is done fine, if the algorithm or the definition which we have done, if it is correct or not. Okay, I think I need to break the line. Just a moment. Display after printing everything. I think I want a next line. Okay, this is what I want. And yeah, fine, let's execute this. So let me show you guys. Let me share the output screen. Only then you would be uh, able to verify yes, our code is correct. You see here. So first line, it is showing you the content of the list, linked list after all the insertion operations. So we are getting 40, 30, and 20 and 10. And the second line, this is actually after performing delete from beginning operation. After performing delete from beginning operation, the list contains this 30, 20, and 10. So 40 has been deleted. So we have successfully deleted a node from the beginning of the linked list. So this is how you delete from beginning, guys. Okay. Harsh, this works. I'm like showing you the code. I'm executing in front of you, and it is showing you the output. This is working. Yeah, it's a 3-day course, Gaurav. It's a fundamental course. So yeah, that's what it is all about. Great. Nitin, there is no PPT here. I'm not using any PPT. I'm just like explaining stuffs in whiteboard and coding it. This code would be shared anyway. I'll be sharing this code in the community. Also, I'll be posting assignment Today's assignment, anyway, I have told you it is you have to perform insert at end operation. Okay, right? Insert at end. Also, you perform delete from end. Two things. Assignment for the previous day, I would be giving it, guys. I have not yet given. So together, I'll post it in the community. Yeah, hi, Aniket. Okay, fine. Now, finally, let's actually go to our like whiteboard, because now I will be discussing some other stuff. Okay, guys, greedy. To be very honest, guys, I won't be like able to discuss every aspect of linked list or whatever topic, but yes, these are good enough to give you an insight and starting with the topics, and it would be a good point when you finish all this 3 day course. It would be a good point on this topic to explore by yourself and all. Okay, right? Anyway, guys, if you like want in-depth discussion of DSA and all, so anyway, you can get enrolled in any of our PGP postgraduate courses, and there this DSA course is embedded along with system design, like in-depth DSA data structure and algorithm courses are embedded, because there we prepare you for placements and all. We bring companies for recruitment and all. So you can always have a look on our PGP courses and check it out. Okay, like you'll get 6 months courses, like everything. Like it may be Python, it may be AML, it may be data science, it may be web development. The whole 6 months you would be like learning the core topic of the respective subject. Along with that, you will be learning cloud computing, AWS. You'll be learning system design. You'll be learning DSA. Also, the non-technical side of the placement. Those training would also be given to you all. Okay, so you can always always check it back. Check out our PGP courses. It's very affordable, guys. If you compare with other e-learning platform, like I can bet on that. So it would be the cheapest one. Okay, fine. So that's all up to you. You can check it out. But the time being, let's start with the greedy algorithm, guys. I'll be picking up some example here. I always say being greedy is not always bad. I'm talking in the concept of greedy algorithm actually. So there are two things, guys: greedy algorithm and dynamic programming. Let me like compare the both, and meanwhile, like I'll be discussing both of them taking together actually. Okay, greedy algorithm, dynamic programming, very important topics. Like almost everyone talking about this two topic when as far as DSA is concerned, or competitive coding is concerned, or getting into a product based company is concerned. Okay, right, nowadays they give you a problem with greedy or dynamic, like any of the coding round. So it's very important. Let's understand first of all what greedy algorithm is, what dynamic programming is, where it is used. Okay, so guys, both this greedy and dynamic programming, greedy algorithm and dynamic programming, both are used in optimization kind of problem. Okay, just have this knowledge, guys, that have this information with you all. Both this algorithm or technique is applied for optimization kind of problem. Optimization means minimize the cost, maximize the profit. Okay, kind of that. Okay, maximize the sales. So all this kind, minimize, maximize, these are called optimization problem. So in such problems we use actually greedy and dynamic programming. Okay, but yes, there are some condition where we can apply dynamic programming, where we can apply this uh, greedy is separate, we'll discuss it separate. But dynamic programming, to apply dynamic programming, there are certain conditions actually. I'll come to that later. Let's focus on greedy algorithm, guys. So as a name suggests, it is a greedy algorithm. It would be greedy for the solution. Okay, for example, if the problem statement is to maximize the profit, let's say the question is the some 4 or 5 products are given to you. Each product, the amount of profit you will get by selling each product would be given to you. Let me write it down. That would be better. Let's say you have a product X, you have a product Y, and you have a product Z. It is said that profit you will get by selling X is maybe 5. Profit by selling Y is, let's say, 3, and profit by selling Z is, let's say, 7, for example. And the question here is maximize the profit. So if it is a greedy algorithm, if you're applying greedy algorithm here, so it would pick this one, guys, Z, because it is giving you maximum profit. So greedy is always greedy about the greedy about the solution actually. So it will always pick the best element, next best element. Okay, what would be the next best element? Next best element, it depends on problem. It would vary from like problem to problem. Like here it is about maximize the profit. So here it would see, okay, if I take product, the if I take the product which is which is having maximum profit, more profit, that is my best element. Okay, right? So it's like if you use Google Map and it would show you the shortcut and also kind of that way you can think. So it'll always go for the next best element, guys. It will always, if for, like in this problem, it will take always the product which has higher, like higher profit, greatest profit as of now. It will take. Okay, right. It has taken Z and it is giving you 7 profit. Next, it will pick X because it is giving the next best profit, that is 5. Right? Okay. So that is how greedy algorithm work. Got it? It will always look for the next best element, next best element, next best element to solve a problem. But guys, greedy algorithm won't always give you the solution. You cannot always reach solution by greedy algorithm. It's just like if you use Google Map and it is showing some shortcut, you might end up in a dead end. Maybe like I am sharing my personal experience. I went to, like, there's a place in Odisha, Raurkela. So I went there. I was not aware of the places, the roads and all. So I just fetched Google Map and I went to some place, it showed me some way. I went into that way and I just ended up with some train track, railway track and all that. I could not find any way. So I just like, and it was very like no proper road, and also I had to return from again and I had to catch the main road and go there. So that's the thing. Greedy algorithm won't always give you solution. Okay, right? So shortcut, like you want to go market, there is a long route and there is a short route. Long route might be very fine road, you can reach by 15 minutes. The short route, you don't know. At the moment, the short route maybe there, it is a kacha road, so it might not be in its best conditions. We might end up taking more time actually to reach the market. So that's the whole point here in greedy algorithm. So greedy is fine, we can use it, but not always it will give us solution. It might fail in some time. Let us discuss. Let us take a problem, guys. Let us discuss on it, and then like it will be very much clear to it. Let's take a very classic problem of greedy algorithm. I'm erasing the all stuff. That is coin change problem. Okay, right. So in coin change problem, what it is given is, it would be given the available denominator. Let's say we are talking about the ATM machine problem. Okay, so we are talking about the ATM machine problem. ATM machine problem. So you went to ATM and you are putting some amount to withdraw. Okay, right. So that's a problem. So available denominations. Available denomination, let's say it has 100 rupee note, it has like 50 rupee note, for example, it has 5 rupee note, it has 500 rupee note, it has 2 rupee note, and it has 1 rupee note. Also it has, let's say, 200 rupee note and 1000 rupee note. Let's, for example, I know like these are not feasible. These rupee notes, like 2 rupee, 1 rupee note, are not available now. It was available long ago, but now it is not there. But for the sake of this problem, let's assume this, guys. So these are the available denominations. So these rupee note are available in the ATM machine, and you have said that you want to withdraw an amount. You want to withdraw an amount that is, let's say, 578, for example. Okay, so you want to withdraw an amount 578. And the question is, you withdraw this amount by having minimum number of coin. Okay, right? Withdraw this amount in such a way that it would have minimum number of coins. So again, this problem is about minimizing the number of coins. So this is an optimization problem. Here we can apply greedy algorithm. So let's see how greedy is applied here, guys. Okay, right? So it is a minimize problem. Minimize the number of coin. So if you want to minimize the number of coin, obviously if you are greedy about minimize the number of coin, so what greedy algorithm will think, if I take coin of largest value, then obviously I would need less number of coin. Am I correct, guys, or not? Just tell me. If I take a note of or coin of big value, higher value, then obviously I'll need less coin. So for example, if I want to withdraw 10 rupee, if I take 1 rupee coin, so obviously I have to take 10 1 rupee coins. Okay, but for the same thing, if I take a 1 10 rupee coin or 1 10 rupee note, then yes, I just have taken one coin, and that makes up the amount, right? So here the problem is about minimize the number of coin. So greedy algorithm would, what it would do is it will pick up the amount which is higher, which it will pick up the amount, it will pick up the coin of higher denominations. Okay, so that at the end it believe that I would have less number of coin in this process. Let's see that. Let's solve this problem, guys. Okay, so what we would do first of all, if I want to minimize the number of coin, I have already told you guys what greedy algorithm will think here. Greedy algorithm will pick coin of higher denomination, so that it thinks that if I take denomination of higher value, then yes, I'll end up taking minimum coin. So what greedy does, it takes the current best element, then it takes the next best element, then it takes the next best element, then it takes the next best element. That is how it works. So you need to arrange this coins in such a way that it would go on, it would take the next best, next best, next best. Okay, so what is the best thing here? This is the best coin, first best coin as per the greedy algorithm. Then this 500, then this, then I think we should add also a 20 here. Then this, then this, not this, 5, 2, and 1. Okay, so you have arranged the coins in some order actually, so that it will be easier for the greedy algorithm to pick up the next best element, next best element, next best element. Okay, right. So basically, if you see here, I have sorted this array, guys. I have sorted this array in descending order. That's what I have done here. Now what would be done here? So this coin would, this algorithm would pick up first. Will try out 1,000. It will try out 1,000, guys. It will try out 1,000, and the amount to be withdrawn is 578. So can it take a 1,000 rupee note or 1,000 rupee coin to withdraw 578 rupees? The answer is no. Okay, I cannot take 1,000 rupee. I cannot withdraw 1,000 rupee coin or 1,000 rupee note if I want to withdraw 578. So this is rejected. It won't be taken. Next, it will try 500. Can I take a 500 rupee coin to make 578 rupees? Yes, I can take a 500 coin. So let's say this is a variable C, which is keeping the count of coins you are taking. So you are taking one coin of 500 rupee denomination. What is the left out amount? What is the rest amount you have to make? You have to make or you have to withdraw. That is 78. Fine. Okay. So 500 is done. Now, can you take 200 rupee coin to make 78 rupee? The answer is no. I cannot take. Can you take 100 rupee coin to make 78 rupee? To withdraw 78 rupee? No, I cannot take. Can you take 50 rupee to make 78 rupee? Yes, I can take. So let's take one more coin of 50 rupee. So total 2 coins now, and the rest of what rest amount I need to withdraw? That is 78 minus 50. So we'll get 28. Right. Now, can you take a 20 rupee coin to make 28 rupee? Yes, I can take 20 rupee coin. So let's take 1 20 rupee coin. So total number of coin would be 3. What is the rest amount you need to make? 8 more rupee you will need to make. Can you take 5 rupee to make 8 rupee? Yes, I can take it. Yes, exactly, I can take. So I'm taking one more coin actually. So total 4 coins. So 8 minus 5 is 3. So I need to make more 3 rupees. Now, can I take a 2 rupee coin? Yes, definitely I can take a 2 rupee coin. So just take one more coin. Total 5 coins has been done. And 3 minus 2 is 1 more rupee you have to make. So finally, you can take one rupee coin. That would make the total amount. So in total, you are taking 6 coins. This is the minimum number of coins here as per greedy algorithm to make 578 rupees, guys. So this is all about your greedy algorithm. This is how greedy algorithm works. I hope you understood through this example how greedy algorithm is working. Just give me confirmation, guys, in the comment section. Did you understand this problem? How greedy algorithm was applied here and how we did here? How it is greedy about the solution? Because it is always picking the coin with higher denomination, if it is possible. As far as it is possible, it is taking up the coin with highest denomination because when it is greedy algorithm, so it would always be greedy about the next best element, and here best element is nothing but taking the coin with higher denomination. Because if we take coin with higher denomination, then we would end up taking fewer number of coin. It's very simple, nothing. It's just we get scared with dynamic greedy, but it's actually easy. It's simple thing. You just have to give a focus and concentrate on the thing. Okay, you need to spend time. Okay, like 3 4 times, and you will get the hang of this greedy dynamic. But yes, guys, it's not about only knowing the concept. It's not about only knowing how greedy works and all. It is about practicing. Okay, how many problems you are practicing on greedy or dynamic? That's where it would make the difference actually. It's not only related to this greedy and dynamic. It's applicable to everywhere, in any subject or any topic, anywhere, right? Okay, fine. Yes, I can do that. I can do that. It would take some time. That's the only challenge. Okay, if you want, I would do it. Let me do it then. The only point I'm hesitating to write the code for this one is I might not get enough time to discuss the dynamic one. Otherwise, I don't have any problem. Okay, anyway. So save it as I'll name it as coin change problem, guys. Coin change, greedy coin change. I'll write greedy coin. Not say. I'll just write greedy coin dot cpp. Fine. First thing first has include stream using namespace std. So I have this main function return 0. Let me zoom in a bit so that it will be visible properly to everyone out there. Okay. There is Gaurav, like there is no specific answer to your question. It's not like you practice 2 question, 3 question, and you'll be done. So there is many number of questions. Do as much as possible on your side. Give your best. Okay. Anyway, like nothing is like enough. Like there are many problems, so you cannot cover all the problem. You cannot do all the possible problem available out there. But yeah, do as much as you can. That's what I would say. So first of all, like we need that available denomination. So to store the available denomination, I'm taking this array, guys. I'll name it as 10. Okay. So what was the available denomination? Josna, could you help me out in this? Like, can you just like read out for me what was the available denomination I had just mentioned, the order in which I had mentioned? I think Josna is not there with me in this streaming platform. Okay, I'll do it. No issue. I guess you can help me, guys. You all in from the comment section. So first thing I had given, I think I don't remember exactly 100. Then I have given. I'm not sure. Can anyone help me out? Please, can you all mention in the comment what was the order of the denomination actually I had given? You can just rewind the video once. Sometime maybe I can do it. Okay, 150, 25, 150, 25. Then after that, what it was? 500, 2, 1, and 200, and then 1000. This is what we had. Yeah, I got it. Yeah, thanks, Prajwal. Okay, so here it is. So as we have discussed already, we need to arrange this element in a way that greedy algorithm can pick up the next best element. If you remember, it was nothing but we had arranged that in a descending order. So we had reverse sorted it. So we have to sort this array in reverse order actually. So that's the whole point here. So I'm not going to use any sorting algorithm here, guys. That would again take more time. So what I'll do here is I can go for something. How many of you know this something called qsort? Do you know qsort, guys? But I think I have bit forgotten the um, syntax of calling this. Okay, fine. This is then I need to send the size. How many elements? One, 4, 4, 6, 8, and 9. I think this would take 9. Then I think it would take the size of each element. Then I have to send something called a comparator function actually, and you need to define this comparator function. Just mark this. This is, I think most of you might not know this. It's a built-in function, guys. Qsort in C, and also you can use in C++ actually. Okay, so this way you can use it to sort the array actually directly without using the bubble sort, insertion sort, quick sort, merge sort, heap sort. You can use this qsort, which is a built-in function, to sort your array. And this CMP, this is a function actually, guys. This CMP is a function. This is the function which will decide whether to sort the array in ascending order, whether to sort the array in descending order. So that depends on what you are actually returning. If I write here this way, if I write here in this way, A minus B, then it would sort the array in ascending order. But if I write this way, B minus A, then it will sort the array in descending order. Okay, have a look. I think most of you might not know this Q sort, right? Okay. So no, absolutely no prerequisite, Sam. Actually, you should just you just have to watch the previous 2 days session actually, day 1 and day 2. Okay. So there is a built-in function qsort in C and C++. Most of the people are not aware of this, guys. Those who research a bit, they know. But yes, most of at least the college students and all, they don't use this much. So there is a built-in function qsort, guys. Okay, you can use it for sorting purpose. Just I need to check only the syntax. I'm not very sure of the syntax. Let me run this code and let's check it out whether it is correct or not. Otherwise, we will take reference. I equal to 0 and I less than 9, because 0 to 8, total 9 elements, 0 to 8 is a possible index range, I plus plus, and for each one I just want to print see out what is this denomination of I. Need a space in between. So let's compile this once. I hope there is no error. Let's check it out. Oh yes, that's error. Qsort was not declared in this scope. I think I should be including something here. Hash include stdlib.h. I think now this should work. Okay, no, it's not working. Hmm, I got the mistake. It should be const. Also, it should be const. Now I think it should work. Let me compile this again. Otherwise, we can just refer. Yeah, I think now it's fine, guys. No error. So it would be const void star a, const void star p, and I want to sort it in reverse order. That's why I've written b minus a. Okay. Those who have attended my previous two sessions, they would understand what I have done here. I have typecasted it. I've typecasted void star into int star. Okay, right? Now let's execute and let's see whether the array is getting sorted in descending order or not. I'll be just executing it right now and I'll share the screen with you guys. Let's see it for ourselves and get confirmation here whether it is sorting it. Yeah, we can use any sorting technique, Shayad, but yes, I don't want to waste our time on that sorting technique actually. Rather, I'd be using a predefined or built-in sorting qsort function, which is there available in C, C++. I can use that. Yep, guys, yes, it is sorting the array in descending order. This is what I'm getting as the output when I'm printing the array after calling qsort. Okay, right? So I'm having the array sorted in descending order just by using the built-in function qsort. So you don't have to worry about in such kind of problem, guys. You don't have to worry about bubble sort or quick sort or merge sort. They will take more time, uh, time to code at least. Okay, don't worry about that. You just use qsort in those cases. You don't want to waste your time, right? When you are in a selection round, when you are in a selection round, then you don't want to waste more time, right? So in those cases, just use this use this qsort built-in function. Okay, now like the task is very simple actually. You don't have to do much. Already have sorted. Okay, so what we need, what extra thing? I need a counter variable which would actually count the number of coins I'm taking. Initially, it is 0, right? And remember, guys, we were checking whether we can take a coin or not. Whether we can take a coin or not. I don't need this loop. I don't want to print the loop. It was just for checking purpose, but it is not the necessary part of the problem statement we are working on. So if you remember, to make 578, first the coin was 1000, so we cannot take it. So there is a checking part. So how can you check it? Someone would say, okay, I will check it by I'll check denomination of I. If it is greater than the amount I want to take, then I'll not take it. Okay, but there is other way around. We really don't have to actually go in that way. So I would just like to take the input for the amount, guys. Enter amount to withdraw. Okay, and we can take the input for this amount. Right. Okay. See, it's very simple. You don't have to check individually whether amount is greater than the whether the denomination you are taking, whether the coin you are taking is greater than the amount. If it is greater, then you don't take it. If it is less or equal, then only take it. But we need not check that specifically, guys. I'll do a mechanism. I'll use a mechanism which will automatically check it actually. Okay, see this what I'm doing here. So for that, I would be taking something called n, a variable n. What is n? N is the number of coin taken of a particular denomination. For example, let's say I want to make 400 rupee. So I cannot take 1000 rupee, I cannot take 500 rupee coin, but I surely can take 200 rupee coin. I can take 200 rupee coin that would make 400 rupee. Okay, so n would store those value actually, like how many coins of a specific denomination you are taking. So that's what n is. Okay, so here n is nothing but n is the total number of coin of a particular denomination. So what you can do here, you can just take amount divided by denomination of I. Okay, see guys, first time amount is 578 and the denomination of I would be 1000. 578 by 1000, it would be 0. So 0 would be stored in n. So that means you are taking 0 coins of rupees 100 denomination. Okay, I hope you are getting it. Then you need to reduce that much amount actually n into denomination of I. Okay, right? Let's say so you were taking 0 coins of 1000 rupee. You have to make 578 rupee. So 578 minus 0 into 1000. Again, you are left out with the same 578 rupee. Next time you will take 500 rupee coin. So n value would be 1. So what would be the updated amount? 578 minus 1 into 500. So 78 would be the remaining amount you want to make it. So that's how it would work. Okay, right? So automatically it will, so it is a way around to not to check specifically whether I can take a coin, whether I cannot take a coin, particular denomination. So I'm just working it around a different way. Okay, right, fine. Next, obviously I need to like add that up. I need to add n in C because C is storing the total number of coin you are taking. So I need to add that n in C here actually. This is the whole thing, guys. Nothing much actually. Only thing is, yeah, fine. Like this is it. That's what you need to do here. Okay, right? Finally, you can. What you can do is finally you can just print here the minimum number of coin is C. Okay, let me once check it whether we have done it correct or not. I'll just compile the code. I hope there is no mistake. Yeah, there is no error. At least there is no syntactical mistake. At least let's check whether it is giving us the correct answer. Okay. So let me share you the output screen. Only then you would get to know. You can easily verify. Enter the amount to withdraw. I'll be taking the same amount, guys, like 578, and the answer was 6 for us. And yes, we are getting 6. So this code is working perfectly, and we are getting the minimum number of coin here. So this greedy algorithm is working, guys, and we are able to solve this minimum coin change problem by applying greedy algorithm. Okay, so it's very easy. It's just like there is a hype, greedy algorithm. But what we did here is we just sorted the array first in some order, and we accordingly, as per the logic, we just we whether we can take or we cannot take, we just counted the number of coins. So simple. It's just simple maths we did. Okay, it's like maybe 6th or 7th class maths kind of thing which we did here. Nothing much. So I hope everyone enjoyed that problem and everyone understood that problem, even the implementation. What is the time complexity of this algorithm? Complexity would be big of, okay, here the number of denomination is fixed. So here it is big of 1, but you never know what would be the like number of denomination. So that depends on the number of denomination n. So then in that case it would be big of n, linear time complexity. Okay, because it depends on this loop actually that we have done. Also one more thing, you can check it out, guys. Q sort, you can check out the time complexity for Q sort. Actually that is a measured time. Even if actually this logic for loop we are running, obviously anyway denomination cannot be infinite. There would be some specific number of denomination, so that would not be that would not take much time actually. That is fine. We again big of that would big of n. The time that the time complexity would be dependent on the sorting time, because here we are sorting the array in reverse order or maybe ascending order or descending order. So that time would decide the time complexity. Rest everything they are constant time. Anyway, denomination, no one would give you infinite number of denomination, not practically possible, right? So it depends on sorting. Even like when it is fixed number of denomination, let's say 5 denominations, so anyway it would be constant again. Maximum it would be even if you think about there are n number of denomination. Okay, in worst case, obviously worst case scenario which we should be talking about, then sorting would take the maximum time here. The loop will take this big of n linear, but sorting time would be more than that, right? You take any sorting logic, it would take at least like minimum n log n, we know, right? The best one. So even q sort will take n log n minimum. So n log n would be the time complexity here. Okay, I hope like you got your answer, Ankush. Yeah, guys, everyone enjoyed this problem? Did you understand what we did here? The greedy algorithm? Just let me know in the comment section, guys, everyone. Great, great. Just consider this question, guys. This is a problem statement, like same like problem statement. We are given this denomination: 7 rupee coin, 6 rupee coin, 5 rupee coin, 3 rupee coin, and 1 rupee coin, and the amount you want to withdraw is 11. Okay, so if you apply the same greedy logic here, so what would it would be? Like first of all, it would take this 7 rupee coin. So 11 minus 7. So it is taking one coin of 7 rupee. So rest amount is 4 more rupee. Okay, it cannot take 6 rupee. It cannot take 5 rupee. So it will take 3 rupee because it is possible. So it will take one more coin of 3 rupee. So left out amount would be 1. Okay, right, then yeah, it can take one more rupee coin. So yeah, total number of coin is 3 and the left out amount is 0. Okay, like we are done with the problem, and the solution greedy algorithm is giving the solution greedy algorithm is giving us is 3 actually. Greedy algorithm is giving us solution as 3. So it says minimum we need 3 coins to withdraw or make 11 rupees, which is incorrect, because it is very clear there. Here if I take one 6 rupee coin and if I take one 5 rupee coin, it is making 11, and actually the answer is 2 coin. It should not be 3, rather it should be 2. Greedy algorithm is giving us wrong answer here. 3, it is giving us 3, but it should be, it is quite clearly visible here. Answer should be 2 coin. If I take one 6 rupee coin, if I take one 5 rupee coin, then I am getting only 2 coin. I need only 2 coin to make 11 rupee. This is the problem with greedy algorithm, guys. It is greedy. It is blind. It always go for the best element. In that process, it might end up not reaching to the solution, because it is greedy about the best element, next best element, next best element. So it saw 7. It is higher, so it took that. But after that, it got ended up by taking more coin for the rest of the amount. Okay. Understood this? Where greedy fails in this coin change problem also, this is one of the situation where greedy fails. So obviously greedy algorithm is not very apt here. If you get this, problem statement, if you get this kind of like denomination and the amount withdrawn is this, obviously it will fail here. So greedy is failing here. It will not give you correct answer. So in such scenarios, guys, you can go for dynamic programming. We can apply here dynamic programming. Yes, okay, because both greedy and dynamic programming are meant for optimization problem. But yes, to apply dynamic programming, there are yeah, I have already sorted it. If you mention the denomination array, I have mentioned it in sorted order 7, 6, 5, 3, 1. I've already mentioned it in sorted order. That is how it is taking the best element, right? It is taking 7, the highest. Then it is not able to take 6 and 5. Then it is taking 1 and 3. So it is ending up taking more coin actually. So that should not be done. It is failing absolutely, it is failing here. It is very clear here. So you can actually go for dynamic programming here. But let's discuss a bit of dynamic programming, guys. It is not always we can apply dynamic programming everywhere. Okay, we cannot apply dynamic programming everywhere. There are certain situation, there are certain condition which we need to follow if you want to apply dynamic programming. First of all, what dynamic programming does? Dynamic programming uses this principle called memoization, not memorization. It is called as memoization. So what is memoization? It's like, let me tell you this. So you'd be given a big problem. A bigger problem would be should be able. Okay, you should be able to divide that bigger problem into small sub problem. First condition. Okay, right, understood. The bigger problem should be should be able to broken up into small sub problem. Okay, second, the sub problem, small sub problem should be repetitive, should be overlapping, or like, yeah, repeating. Same sub problems might overlap or might occur again and again. In those scenario we apply dynamic programming. Understood, guys? What is the condition? A bigger problem, you should be able to break the bigger problem into small sub problem, and those small sub problems should be repetitive. Okay, same sub problem should be occurring again and again. So in those cases dynamic programming can be applied. Okay, right? So what is memoization means, what exactly is this? Once you have found a solution of a sub problem, understood, guys? A bigger problem is divided into small sub problem, and that sub problem should be overlapping, or it should be repetitive. It should reoccur at some or other places. Then you can apply quick sort. So what we do, sorry, then you can apply dynamic programming. What we do is we find solution of each sub problem, small sub problem, and we combine them together to finally find out the solution for the bigger problem, the main actual problem. That is what we do in dynamic programming. Okay, and in that process what we do, once we have found solution of a small sub problem, we store it somewhere. So remember what I have told, the sub problem, the smaller sub problem should be repetitive. Okay, right? So when you have found answer for a small sub problem, you store the result somewhere in a table, in a table excuse me, in a table you store it. So when the same sub problem occurs anywhere at any point of time further, you reuse that solution that was stored. You don't recalculate it, you just reuse it. Okay, right? So just to make you aware of this, let me take up this problem of Fibonacci series, guys. For Fibonacci, if you remember, if you have seen the recursive definition of Fibonacci, it is nothing but Fibonacci of n minus 1 plus fib of n minus 2. Okay, so if I talk about Fibonacci of 5, let's say, so it is broken up into like Fibonacci of 4 and Fibonacci of 3. Then since Fibonacci of 4 is broken up into Fibonacci of 3 and Fibonacci of 2, and this is broken up into Fibonacci of 2 and Fibonacci of 1, and this is again Fibonacci of 2 and Fibonacci of 1. Yes, it's actually plus. Oh, this is not plus, my bad. Yeah, this is plus here. Okay, similarly, you go on dividing it, divide it, guys. Like this is Fibonacci of 1 and this is Fibonacci of 0. You'll get this as Fibonacci of 1 and Fib of 0 plus. Okay, this is Fibonacci series definition. If you see the recursive definition, actually. Okay, so this is the thing I'm talking about, guys. Maybe fib of 1 will return you directly 1 or something. Fib of 0 will directly return you 0 or something. Okay, right? So you store this solution, actually. You store this solution somewhere. If you see here, these sub problems are repetitive, guys. This fib of 2, here you'll find, here you'll find, here you'll find. Okay, this fib of 3, see here it is fib of 3, even here it is fib of 3. So the sub problems are repetitive in nature. Even this fib of 1, if you see, it is repetitive in nature. Fib of 0, this is repetitive in nature. So dynamic programming says the smaller problems, when it is reoccurring, you don't have to calculate it again, you don't have to find the solution again. If you have found it already before, you store it somewhere, and if you come across some same sub problem, just use that solution here, because obviously it would give you the same result, same answer. That's the whole point of dynamic programming. But to use dynamic programming, as I said, it should follow these two conditions. Problems, you should be able to divide that problem into smaller sub problem, and the smaller sub problem should be repetitive. Okay, should be overlapping. Like here, it is being happening. Okay, so if you don't apply dynamic programming here, guys, then it will give you time complexity of 2 to the power n, because in each function, like in each step, you are getting like this is 2 to the power 0 functions, it is 2 to the power 1 function, it is 2 to the power 2 function, here you will get 2 to the power 3 function call, and so on. At the end, like you will get 2 to the power n order. Actually, time complexity would be 2 to the power n if you just use a simple recursion of Fibonacci series. If you go with the Fibonacci series recursive function definition, that's why we don't use recursive definition of Fibonacci series, because if n grows, then it will take 2 to the power n time complexity, which is very huge. So we apply actually dynamic programming in Fibonacci series. Okay, dynamic programming solution we apply. I don't want to get into dynamic programming solution of Fibonacci series. Maybe we can do that later in some other time. Okay, so maybe somewhere if we take some other session, maybe some extended session of DSA, some more days of session, then maybe we can pick it up. But right now, what I want to discuss is like, I hope I wanted to discuss where we can apply dynamic programming. I hope you got it, guys. Okay, where we can apply dynamic programming and where greedy fails, and that we can apply greedy programming that place actually. Okay, right? So just allow me some more time, maybe 5 more minutes. I'll show you guys how we can apply dynamic programming in that problem, coin change problem, and we'll get our answer. Okay, right? So the denomination we got is what was the denomination? Okay, we had 7, we have 6, we have 5, and we have 3 and 1, I suppose. Okay, and the withdrawal amount was 11 rupee. So what we do in dynamic programming is we just make a table, actually tabular manner, because we need to store the result of each sub problem solution, right? So we draw a table, and when we find the solution for each sub problem, and we go on storing it, and then we reuse whenever it is required. There are two approaches, guys, actually in dynamic programming. DP, dynamic programming, it follows two approaches. One is top down, and one is bottom up approach. Bottom up approach is the most preferred one, and that is what I'm going to use actually. Right, okay, so here what I'll do is I would draw a table. So I'm writing here the available denomination: 1, 3, 5, 6, and 7. Okay, right. And this side I'll be writing the amount actually. So when I write amount, it would be generic. Dynamic programming is a generic solution, guys. If it would give you answer for if it would give you answer the minimum number of coin to take 11 rupees, then it should also give you answer the minimum number of coin required to withdraw 5 rupee. It is generic solution. So you need to write every possible amount to withdraw: 1 2 3 4 5 6 7 8 9 10 and 11. I think this would be big. I think I should change the yeah, that's guys, I will change it, because this would take much time actually if I take so many numbers. Maybe we can change the denomination as a withdrawal amount. Let's say we'll make it 7, and denomination I can take as 5 4 3 1. Okay, even the same condition applies here guys. If you check out, even cross check, the same condition arises here. You cannot like greedy will not solve the problem here actually. Okay, so let me just change this, also this. Okay, so I have 1 rupee coin, I have 3 rupee coin, I have 4 rupee coin, and I have 5 rupee coin. And the amounts, possible amounts: 1 2 3 4 5 6 and 7. Okay, so my bad, just give me a moment. I'm a bad artist, you can say. Not artist. So I need to draw this tabular manner actually. I think I should take one more column and row, just to fill up for 0 coin and 0 coin guys. I think I should take it. That would be better, right? Okay. So 1 coin, 0 row and 0 column actually. Yes, I want to take it. 3 4 5 6 7. So let's draw this stuff. Okay, so I have drawn this table, and right now we'll start putting the values. We'll solve each one of them and we'll start putting the values. So initially guys, we are in this column. That means we want to withdraw 0 amount. So obviously we don't need any number of coins, so just put 0. Okay, so also if you talk about this 0th row, this means available denomination is 0 rupee. So obviously we cannot take any coin of this like denomination. So just put this 0th row and 0th column 0 0. We cannot take 0 rupee coin. So every number of coin would be 0 0. Also, I cannot take 0 rupee coin to make any amount. To make 0 rupee, I cannot take any coin. So the entire column is 0 0 0, and I cannot take any coin of 0 rupee denomination. So the entire row of this 0 is 0. Entry is 0. Okay, I hope that makes sense to everyone. Now, when we are at this row, what actually means when we are going to each row? This means you have plenty of 1 rupee coin. When we are into the second row, it means you have plenty of 1 rupee coin and 3 rupee coin. Like there are infinite number of 1 rupee coin and infinite number of 3 rupee coin. When you are at this row, then it means you have 1 rupee coin, 3 rupee coin, and 4 rupee coin. Each coin is available in ample amount, guys. Okay, abundance of, no shortage of coin. Infinite number of each denomination is available. Similarly, when you are at this row, it means you have 1 rupee coin, 3 rupee coin, 4 rupee coin, and 5 rupee coin. All possible coins you have. So this is what you need to keep in your mind. It is not only you have only 5 rupee coin. It actually means you have all the coin, like 1 rupee, 3 rupee, 4 rupee, 5 rupee. It gradually gets added up actually. Okay, so this is it's a small thing you need to keep in your mind when solving greedy algorithm. Now, coming to this column, I want 1 rupee total. I want to withdraw 1 rupee. So now I'm talking about this row. So I have only 1 rupee coins available. How many 1 rupee coin I can take to make 1 rupee? Answer is very simple. I can take only 1 rupee coin to make one total 1 rupee. Okay. Then let's talk about 2 rupee. So the total amount you want is 2 rupee, and you are at this row. That means you only have 1 rupee coins. How many 1 rupee coins you can take to make 2 rupee? The answer is 2. So you just fill it up. These are number of coins, guys. Okay, I'm filling it up. So minimum I'll need two 1 rupee coin to make total 2 rupee. Similarly, I'll need 3 coins of 1 rupee to make 3 rupee. I'll need 4 coins of 1 rupee to make 4 rupee. I'll need 5 coins of 1 rupee each to make total 5 rupee. I'll take 6 coins of 1 rupee to make 6 rupee total, and I will need 7 1 rupee coins to make total 7 rupee. So this is the row for first, like the row 1, I can say. This would be the entries of it. I'm storing it. Okay, I hope everyone is following. Now we are at the third row. That means now I have both 1 rupee coin and 3 rupee coin. I have both options. Either I can take 3 rupee coin, either I can take 1 rupee coin. Just get back to here from again. I want total 1 rupee. So first of all, you will see, can you take 3 rupee coin? The answer is no. I cannot take a 3 rupee coin to make 1 rupee. So will not take it. So in that case, what you will do, just copy the previous value. You copy the previous value, guys. So you just copy it here, 1. Yes, this is all about reusing, guys. This is all about the memorization I was talking about. I'm reusing the previously stored value here. I cannot take 3 rupee coin here, so I'll just copy the previous value. Similarly, now I am here in second column. I want 2 rupee total. Can I take a 3 rupee coin? Answer is no. So what you will do? Just copy the previous value. Okay, so I cannot take a 3 rupee coin, so I will take two 1 rupee coin. This means how many coins you are taking, guys, to make this 2 rupee. So you are taking two coins total. Okay. Now you are at this column. So you want now total 3 rupee. You want to make 3 rupees here. And can you take a 3 rupee coin? Answer is yes, I can take a 3 rupee coin. Okay. So the amount is 3 rupee. And you are saying you would take one coin of 3 rupee denomination. So what is the rest amount? 0. Okay, right? So what is the remaining coin you have to take? That you will get, guys, in the same row. If you look up in the 0th column, it will give you. Why 0th row I'm checking? Why 0th column I'm checking? Because the remaining amount you want is 0. Okay, so finally it is 1 plus 0 is 1. It will make sense, guys. Don't worry. If you are not getting it right now, just give me with just be with me when I like the same process I'll be following for cover, like for filling all the cells here. So you would get it actually what I'm trying to do. So what you are getting actually 1 coin. So it is not like you just put here 1. You need to check what is the previous value. 3 coins. What is the current? Now what result you are getting? 1, which is minimum. 1 is minimum. So you write here 1. So you will take 1 coin to make 3 rupees. Okay. So it is not about just filling up the coin. You need to check whether the previous value is minimum or the new value which we got right now is minimum, because the problem is about minimizing the number of coin or the minimum number of coin you require to make an amount. Okay, right? It's a generic question, guys, generic solution. So you need 4 rupee total. Can I take 3 rupee coin because you are on the same row? Yes, I can take. Okay, I can take. Right, so I can take, so 4 rupee. I'm taking 1 coin of 3 rupee. What is the rest amount? Rest amount is 1 more rupee I need to make. So what is the now extra number, like how much more number of coin you want to take, you have to take. So you don't have to worry, you don't have to calculate again, guys. What you need to check it in the same row, just come to this, just come here in the column 1 and take this value 1. So 1 plus 1, that is 2, which is minimum. 2 or 4, previous value is 4 and now we are getting 2. Obviously minimum is 2, so you write 2. So you'll be taking 2 coins to make 4 rupees. Okay. right? I hope you are getting, guys. My bad, just give me a moment. Anyway, I'll be like repeating the same procedure actually, so it will not be a problem to you. Fine, let's now talk about making 5 rupee. So can I take a 3 rupee coin? Yes, I can take a 3 rupee coin. So okay, I'm taking one coin of 3 rupee. What is the rest amount I want to? I need 2 more rupee. So what is the remaining number of coin I need? Just check. Just go to the column 2 in the same row. What is the value there? It is 2. So 1 plus 2, that is 3. Which is minimum, guys? Previous value or new value? Previous value is 5. Now I'm getting 3. So 3 is the correct answer. Okay, so see guys, what I'm trying to do, what I was trying to say when I was saying that it is generic actually. If the question is if the question given as withdraw 5 rupee and the available denomination is 1 and 3, then what is the minimum number of coin? Then answer is 3 coins total you would need. Okay, right. Then similarly, if let's say the question is available denomination is 1 and 3 and the withdrawal amount is 6, what is the minimum number of coin? Let's find it out. Let's see here. So you want to withdraw 6 rupee, right? Can you take a 3 rupee coin? Answer is yes, I can take. So you are taking one coin of 3 rupee. What more? What is the rest amount you want to make? You have to make, that is 3. So what would be the, like what, sorry, not this, what would be the extra number of coin you want to take here? Okay, so nothing guys, you don't have to worry, just in the same row go to this 3 rupee column, take that value, that is 1. So you are getting the answer as 2. Which is minimum, previous value or the new value? Previous value. Previous value is 6, new value is 2. So you write 2. Answer is 2, guys. So if the question is withdrawal amount is 6 rupee and the available denomination is 1 and 3, so the answer would be 2, 2 actually. Okay, right? Similarly, if you talk about 7, same thing you proceed, write 7, amount is 7. So can I take a 3 rupee coin? Yes, I can take a 3 rupee coin. So just take one 3 rupee coin. What is the rest amount you want? 4 more rupee. So what is the remaining amount of coin you need to take? Simple. In the same row, go to the column 4 and take that value. 1 plus 2, that is 3. 3 is less than 7, previous value. So answer is 3. So if the question is given that available denomination is 1 and 3 and the withdrawal amount is 7, then the answer would be 3. Minimum number of coin would be 3. Similarly, guys, you need to fill up all these cells applying the same procedure, whatever I have been doing here. Finally, this cell, whatever answer you will get in this cell, that would be the final answer for our given question. Okay, available denomination is 5431. Okay, and withdrawal amount is 5. Let me fill up one more row. Just give me 2 more minutes, guys. Just let me fill one more row, then you would easily understand it and you can do it. Okay, right? So let's do it now. Again, now you are at this row and you want to make 1 rupee. Can you take 4 rupee coin? No. So just copy the previous value. Similarly, yeah, now you are here. You want to make 2 rupee. You want total 2 rupee. Can you take 4 rupee? No. Just copy the previous value. Fine. Now you are here. You want 3 rupee. Can you take a 4 rupee coin? Answer is no. Just copy the previous value. Now you are here at 4 rupee. You need 4 rupee. Can you take a 4 rupee coin? Answer is yes. Okay. So let's talk about that. Let's take this. Now the calculation would begin. Now we need to do the calculation. We'll see like how many coins and all. Let me just clear out this area once. It's very easy, guys. It's a simple process. Only thing is people have created hype about dynamic greedy. But if actually see, it's a very simple process. But you need to practice a lot. Otherwise, it would take a lot of time to solve such kind of problem. Okay, so I'm talking about I need 4 rupee. Can I take a 4 rupee coin? Yes. So I'll be taking one coin of 4 rupee. Remaining amount is 0. So what remaining coin I would take? In the same row, go to this zeroth column. So value, take that value, that is 0. Total you need one coin. Which is minimum? 1 or the previous value? Previous value is 2. Now we are getting 1. So answer will be 1. Okay, right? Similarly, now you want to make 5 rupee. So can you take a 4 rupee coin? Yes, I can take a 4 rupee coin. So 5. I'm taking one coin of 4 rupee. So the remaining amount is remaining amount I want to make is 1 more rupee. So what would be the remaining amount number of coin? Same thing. Just go in the same row. What is the remaining amount you want to make? You need 1 more rupee. So take that value, that would give you the remaining amount of coin, remaining number of coin. Total is 2 coins. What is the previous value? Previous value is 3. What is new value? It is 2. Minimum is 2. So you would go for 2. Okay. Next, so you want 6 rupee. Can you take 4 rupee coin? Yes, definitely I can take a 4 rupee coin. So just take one coin of 4 rupee. Remaining amount is 2. So what is the remaining number of coin you need? Same thing, just in the same row, go to the column which is representing 2 rupee, guys, and take up that value, that is 2. So 1 plus 2, that is 3. Which is minimum? Previous value is 2. Now you are getting 3. Minimum is 2. Just copy the previous, just write the previous value, not the new value. Minimum, always write the minimum, guys. Okay. Similarly, now it is 7. So same thing. Can you take a 4 rupee coin? Yes, you can take a 4 rupee coin. Take one 4 rupee coin. Remaining amount is 3. So what would be the remaining number of coin? To find that, just in the same row, go to this column, which is actually 3 rupee column. Value there, you take it up, that is 1. So answer is 2. Previous value is 3. Now you are getting 2. Minimum is 2. So you write it. So in this way, guys, fill up the last row also in the same way. And the last cell, this cell would give you the answer finally. This is how you solve greedy programming question. For the same coin change problem, minimizing the number of coins, we applied here greedy algorithm, and definitely it will give you correct answer. By this time you'll get to know. See, by this time you'll get to know, because here it is already giving us 2 by taking 0 rupee, 1 rupee, 3 rupee, 4 rupee. So when you talk about 5 rupee coin, even if you take 5 rupee coin, it will take one 5 rupee coin, then it will take two 1 rupee coin. So it would give you answer as 3 actually. But minimum, previous value is 2, so you would write here 2. Answer would be 2 finally. So this will come to you automatically, guys. When you solve actually more problems, 3, 4 problems, then you can actually easily get to know. Okay, I hope like I made justice, guys, to your time, and I hope that you could follow. Not like this is not rocket science; it's just a technique. It's just a way which we are following, which we are applying. Simple thing. Did you get it, guys? Understood this? This problem, minimum coin change problem using dynamic programming. Is it clear? So in interviews, they might give you some problem like this. They can ask you what would be the minimum number of coin. So you have to actually draw this table and solve this and tell the interviewer the answer. Yes, this is the minimum number of coin we would need to take this amount. It's so simple. Okay. So almost like if you talk about any greedy dynamic programming, almost the approach is same actually. Only thing is you need to figure out what to write in the row, what to write in the column, and then you are sorted actually. Okay. Yeah, guys. So that was it. Like that was the basic thing I was discussing here. I am done with my discussion for this day. Okay. Like I hope you enjoyed all this 3 day session, guys. I enjoyed a lot. And I hope that this all these relay sessions was fruitful to you. Always, I would also repeat again, guys, if you like want like more in-depth discussion on this data set algorithm, which would really help in your placement, then you can always look up our PGP courses, guys. Like you can learn other stuffs like Python or web development. Along with that, you will also be trained with data science algorithm, system design, AWS, and all. Anyway, like also you'll be getting placement opportunities here in Let's Upgrade itself. Okay, we being companies for recruitments and all. Yeah, okay, fine. So my part is done, guys, for this batch, for this data master data science and algorithm C++. But you have one more session, that is your career and placement guidance session coming up Monday, 7:30 p.m. So I hope every one of you would join there also. So I'll not be there, but yes, because it is actually non-technical part of placement preparation and all. I'm not good with the non-technical part, so I'll not be there. I am focused here on the technical part. So Sneha ma'am would be there. She would be actually taking it ahead, the career and placement session. So you can attend that session. That is actually a part of this DSA session only, guys. Okay, so you check it there. Okay, fine. That is also important, and even you have to like put attendance for that session also, guys, for the certification purposes and all. So that's all, guys, for this DSA. You'll just have the placement and guidance session actually, and what there is you. I'll post assignment for today's assignment. It is already I have announced. It is nothing but you define insert at end and delete from end operation. Previous day assignment, actually I think I have not put it yet, so I'll be putting that also today. Okay, don't worry. So both the assignment I'll put. Also I'll upload the two code. One is for the greedy solution of coin change problem, and one is the linked list thing which we have implemented. I'll give it. Okay, I'll upload it in the same community group. Do check out the community group, guys. Maybe after half an hour or maybe 1 hour, you can check. It will be done. Anyway, you have deadline to submit assignment, guys. Like today 28, right? You have 29, 30, 31st. Yeah, 31st August by midnight you have to submit all the assignment. Do check the assignment submission form link. It is like everything is mentioned there, how to submit and all. Just submit it there, and it will be reviewed and it done. Just one request, guys, just please do give us some time, because lots of assignments and project submission are being done, so we would take some time to review them. And also, as we are sending physical copy of completion certificate, so it might take some time to get delivered to your address, respective addresses and all. Okay, so that's it. That's from my side. So thank you, everyone. Thank you for joining. You are like a very amazing audience actually. Okay, I hope this was fruitful, and I think it would help you a lot in future. Okay, you can explore from yourself also if you want. So that's it. That's it for this day. Thank you, guys. Thank you, everyone. Bye bye, and take care till we meet next time.